Alright, problem 7. A bullet is shot into a pool. The bullet enters the water with a speed of 350 meters per second. It slows down to a stop in 1.5 seconds. Calculate the acceleration of the bullet underwater. Alright, so let's start to label. Givens. Things provided in the problem. 350 meters per second. This is the speed it started with, so you should have labeled this VI. Meters per second. Alright, it slows down to a stop, so the final velocity, VF, is 0. If it's stopped, it has no speed. It does this in a time of 1.5 seconds, so that gives us our delta T also, 1.5. Alright, our unknown, what they ask us to find is acceleration. Acceleration equals question mark. Now the equation on the board that you should use that will help you most for this problem for acceleration is velocity final minus velocity initial divided by time. We know what all three of these things are. Velocity final, velocity initial, and time are all in our givens. So we just have to plug those in. Acceleration equals our velocity final, we said was 0, came to a stop, minus our velocity initial is 350, divided by the amount of time it took to stop, which was 1.5 seconds. Alright, the last step, simply to solve that. 0 minus 350 gives you that negative 350, divided by 1.5. If you put that in the calculator, you'll get a negative 233.3 repeating, so we can just put 0.33. And the label for this, don't forget your label, it's an acceleration, so it's meters per second squared. Big acceleration. Alright, B. How far did the bullet travel underwater? Well, let's remind ourselves of some of the givens that we know. We still know what velocity it started with. Velocity initial was at 350. We also know our acceleration. We just found it. It's at negative 233. And we knew that the time still is at 1.5, the time it had to move. The unknown, what they ask us to find, is distance. Distance is that delta x symbol, and you have an equation for that. So our equation for distance is equation number 2 on the board. I'm going to stretch this out because I don't have a lot of room, so I'm going to start by writing the entire equation. Delta x equals velocity initial multiplied by time plus 1/2 acceleration times time squared. We have to plug into this equation. To do that, our velocity initial, we said, was 350. We have 350 multiplied by our time, which is 1.5, plus 1/2 our acceleration of negative 233 times our time again, which is still the 1.5, but we have to square that. Alright, if you do all your math correctly, you multiply each side and then you subtract at the end, you'll have a 240, or sorry, that's not correct. Let's change that real quick. 350 times 1.5 is 525. Since there's a negative over here, you'll end up subtracting 1.5 squared and then multiplied by 233 and 1/2. You'll end up getting 262.5 if you do it correctly, or it should be close to that. Subtracting those two actually gives you the same answer, 262.5. That's your final answer for this problem. If you got an answer that was really close to that, you probably just rounded differently than me. Remember, if you mess up on the math, it's okay. It's not a math class, so I won't take off points, but you need to show me enough work so I can see where you might have made your mistake, or else you'll get multiple points taken off. Alright, our very last problem. It's an easier one. An exceptional drag race car has an acceleration rate of 28 meters per second squared. From rest, what speed can the car reach in 10 seconds? So let's write down our givens. They gave us acceleration, 28 meters per second squared. From rest, that's telling us it's starting with a velocity initial of 0. It has 10 seconds to move, so our delta t is equal to 10. Unknown. What the problem asks us to find is what speed can the car reach? It's asking for velocity final. So the equation for that, velocity final, is equal to velocity initial plus acceleration times time. And we know all three of those things. We just have to plug them in. So velocity final will equal our velocity initial, we said, is 0, plus acceleration, which is 28, multiplied by our time of 10. So adding 0 to something doesn't change anything. The final answer will just be 28 multiplied by 10. So our velocity final is equal to 28 times 10, which is 280. Since it's a velocity, our label is meters per second. A much easier problem. That should be your final answer. Alright guys, make sure you understand how to do all these problems and that you're ready for tomorrow. Good luck.